Hi there, welcome back. Welcome back to the last video. That's video number 4, I think it is, in the restoration series for this Zenith Trans-Oceanic Royal D7000Y. And as you can see here, it's now done. It's done. There's still quite a lot of stuff that I had to do since the last video, so I'm obviously recording this at the end. But this thing came out fantastically. It really did. I did go through all the alignment, which I'll show you if you continue watching the video. The full alignment of the RF on all the AM bands. I show some of them. I skip over some others. They really can be monotonous. Believe me, it's monotonous to do. It's monotonous to watch. But the result is well worth it. This thing is beautiful. The condition is amazing. The owner looked after this fantastically, and I hope now it's giving him another bit of impetus to keep looking after it and treasuring this radio. So if this sort of thing interests you, stick around. At the end, there's a full demo of reception. Let's have a look at this supply. Now, I took that screw out, but someone has definitely been in here. It's not too difficult to tell because the wires have been moved from there, but more importantly, I can see burn marks on those capacitors. I can see soldering has happened over there, not very neatly, but more importantly, I can see cut wires on there. You see that red one there? That's been cut. And when you take this out, you see something else. We see another cut wire over here. The switch is actually correct, but the wires on here have been cut. So 2 wires have gone from there. And why is that? Oh, okay, you see these 2 green wires? This is coming from the mains in. That's going straight to the transformer. There is no switching whatsoever between the 230, what is that, 230, 115, so there's no selection anymore. This is not acting as a switch anymore. It's just two tags, and the reason is the transformer has only got 2 wires going in there. So there's only one primary. There isn't a dual primary like the multi-voltage types. The way it works is that if you look at the schematic, the transformer has got 2 secondaries, or two primaries rather. They're actually both 110 or 115 volt primaries. And if you put them in parallel, you operate that, and that's what this does in parallel. It operates it as a 115 volt input. If you put the 2 in series, it operates as a 230 volt input. So this transformer is not original, or it can't be original. It can't be original because that switch has been bypassed. But this is the transformer I've got, and that's the one I've got to use. So I'm going to just clean that up a little bit more. I don't like the way that's done. And also this here is pretty shoddy. I've got to replace that capacitor. In fact, what I'm going to do, these diodes on there are rated properly for this device, but I'm probably going to put in 1N4007s in there just to make sure this thing lasts forever. Okay, that's what I'll do. Next time you see it, it'll be in. I want to neaten the wiring on here, and the back will be ready to go in. Now, the only other things we've got on the back are these 2. This is the antenna. This goes to that antenna that comes out the top here. Okay, so this goes to the antenna connector on the back of the radio. And this here plugs into that RCA on the back of the radio, which is the output from the tuner. So effectively, this lets you take the signal from the radio and put it through another amplifier. It's a little bit of a strange, it's actually a jack switch over here, but a jack socket. But it's a mono signal, no big deal. So that gets plugged in when you put the radio back. Nothing else seems wrong. It may have been something removed from here, but I don't think so. The selector switch here is okay. The middle is the one that goes to this connector, which is the 12 volts. And then, as you can see, left and right, it'll take it from the battery compartment here, or that orange wire, which is the output 12 volt output from this supply. I've actually tested it. It's not giving me 12, it's giving me 16, but that's normal because it's unloaded. So there shouldn't be anything else wrong with this. In order to complete this little section, I just wanted to show you the result. I am measuring that point there, which is the plus and ground. The other little dot there, the other little socket, goes to the 1.5 volt battery over there inside the battery holder. At the back here we've got a selector switch, which is AC or DC, battery or AC. So this is AC. If I push it to the other side, it'll be battery. And we're getting 16.8, about 16.8 volts DC. Now, I've rebuilt this whole thing. It was a total mess. All these wires floating around. I don't like that sort of thing. And a lot of these components were completely buggered. I mean, look at that. That thing was in really bad shape. These are 500 volt caps. The ones I've got in there are 1000 volt. I've got two 1N4007s. I've got a new flame-proof metal oxide resistor, 15 ohms. The capacitor was a 500 microfarad. This one here at 20 volts. I've got a 680 microfarad, 35 volts. Doesn't make much difference. It's the size I was looking for to make sure it fit there nicely. All the solder lugs were cleaned out, and I rebuilt that just so that everything works a lot better and is a lot neater. Those diodes were okay, actually. These diodes were fine, but I don't know for how long they would be fine. These things are tough little buggers, but they're replaced now with new 1N4007s. So our external supply is done, and this means I can carry on with the other bits. I'm going to start now with the RF alignment, and I'll start with the medium wave, just as they tell us to do over here. They say place the bandwidth switch on normal and turn the BFO to off. In other words, you don't leave it on sharp. BFO is off because you don't want to interfere with the reception, with the test. Now, all these steps here have to do with the medium wave or the broadcast band, and they tell us to use one loop loosely coupled to the wave magnet. This is great because you don't actually have to connect the signal generator to the radio itself. You just get a loop of wire, connect the signal generator to it, place it near the ferrite antenna, and you're good to go. Now, what do you need to do? They're talking about the input signal here, the band you're working on, the dial frequency, and what you adjust and what the purpose is. So if we look at this thing here, it says, first of all, 1620 kilohertz. Now that's right at the edge of the dial. So you turn your dial, you turn your tuning all the way to the right. It's a full gang open over here. And you then adjust C116C, we'll see what that is in a minute, C116C, to get the highest tone. In other words, to tune it in as best as you can. And that means you're setting the right end of the scale to receive 1620 kilohertz. It tells you here, set broadcast oscillator to scale, or BC oscillator to scale. You do the opposite then with the 600 kilohertz, which is on or close to the left edge of the scale, also on broadcast band. You dial the frequency in at 600 kilohertz and you adjust C136. So what you're doing is you're adjusting the right-hand end, you're adjusting the left-hand end, so you're effectively stretching the dial to correspond, or stretching the tuning range to correspond exactly to your dial that you're seeing in front of you, okay? Then it says repeat steps 3 and 4 until maximum change. Now, what are these adjustments that we need to do? Let's have a look. Now, this is pretty easy because C119 is over here, and 119C is that guy over there. So there's C119, and you got A, B, C, and as you can tell, there are tuning condensers, the little trimmer caps. And then they tell us to tune C136 when you go down to 600 kilohertz, and that's another trimmer here. So they're all visible, and they're actually very close. So what I'm going to do is set that up, do the one, do the other, go back, because you do have to iterate between them to make sure that you get the right stretch, because that one affects that one and that one affects that one. So that's what we do next. But let's have a look at the next stage so we can do that all continuous. The next stage is they tell us to set it to 1420 which is nearly at the top of the dial. That's your input signal. And you tune it to 1420 and you adjust C112, 119A. That's align the broadcast antenna and mixer for maximum. So what you're then doing is now you're making sure that your front end, your antenna circuit and your mixer circuit and all the circuitry at the front end of the radio is perfectly maximized, optimized to the band that you're working on. So let's have a look at that. C112, C119A, and here we are. C112 is that guy over there. That's right by the antenna, okay? 119A is over here. Remember we adjusted 119C. Now 119A is over here. Now this is being done obviously with the chassis inside the cabinet. So all the protection, the screening, the RF screening that you're going to have when the radio is closed is already in place. This will give you the best possible adjustment that you can make. And then you set it to 600, you adjust L122A. And again, you repeat these steps. So let's get to the radio, now that all the explanation is done for this, and let's set that up. Right, first things first. I'm going to set this to 1620. Amplitude, I don't know how much I need. I'll put 20 millivolts. Remember, this thing is not going to touch the radio itself. It's connected to this loop. That's it here. And what I have is a modulated tone on there, and it should be AM modulated. Yes, it is. It's a 1 kilohertz signal. Yes, it is. And we're back to here at 1620 kilohertz. Set the output on. Now this thing is radiating out of that coil, which should be picked up by the ferrite antenna on the radio. Let's switch it on and see if we're getting something. Okay, here we go. This is on normal. The bandwidth. Whoa, it's there. So that's pretty clear. I don't know if it's maxed because it actually hits the end, as you can see. But it looks like it's a little bit off. The center of that signal is a little bit off. What I'm going to do is reduce the amplitude from the signal generator. I think it's still off. So what I need to do now is just to try and peak it on there. What happens if I put narrow? I'm surprised you have to do this on normal and not on sharp. But it does say normal, so we'll leave it at normal. Okay. So here we are around the back. I've got a AC millivolt meter connected to the speaker terminals, which we'll be able to watch for amplitude where we need to. And we've got these capacitors here. This is C119. There is C119A, B, C. That's the one we need to adjust according to the instructions. So we'll put the volume up. We'll watch the meter. Now let me tune off and tuning off. Of course it's getting noise as well. But there's our signal. Let me try and get a little bit of a clearer signal. You shouldn't do this with the volume too high, with the signal strength too high. But if I go to here, 119C, see that's going off. That is, the meter doesn't actually help me much, does it? But that is clearly, you see what's happening here is I'm getting a signal on the meter with noise. So it's actually giving me quite a bit of amplitude. If I do that, I get a perfect signal. And if I go off the other end, I get amplitude with noise. That tells me that I think the AGC kicks in. Let's try something. I'm going to try something which is not that conventional. I'm going to switch on the manual gain control. Okay, now it's on minimum. If I switch on the manual gain control, we'll see if we get it better. Okay, there we go. Now what I have, theoretically, is something that doesn't get affected by the AGC. Let's see what happens here. That is a perfect example of where the AGC messes up my readings. Perfect. See that? That's my noise, right? Now my signal is stronger, and you can see it come up. I went too far. See it come up, and there's no automatic gain control to bring it down artificially. So that's my peak over there. Brilliant. I like that. Let me now go to, what do they say? 600. I've set 600 kilohertz to the signal generator. I've got it tuned down exactly to 600. It is perfect. I'm looking at it straight on. You're looking at it from the side. This thing is perfect. There's nothing to change here. But if I had to change it, I would adjust that guy there. Now, because I know that I've adjusted the top end, 1620, and I know the bottom end is in perfect condition, perfect placement, I don't have to go up again. Otherwise, I would have to go up again. Now, the next thing they tell us to do is to set it for 1420. So 1420 kilohertz. And now I've got to tune it to 1420. All right, there's 1420. And now they tell us to adjust, what is it? C112, which is that guy there, for a peak. Oh, it's going down, it's going up and down. That's it, that's peak, that's the antenna circuit. Then they tell us to adjust C119A, which is again down here, that's A. That seems to be, that's gone down a bit. If I push it, I'm actually doing what the capacitor is doing, so I've got to do it very lightly. That's a peak. And now they have us adjust they have us take that to 600, which I'll do. And I'm going to tune down to 600. Okay, and they tell us to adjust L122A. According to that drawing, is this guy over here. And I think A is the front end. So I'm taking this guy here, which is a little hex tool, which has then been tapered down afterwards. So the front end fits in, this one slips through, and then it goes onto the front. Pushing it right through the first core, trying to find the second core. I found it. Let's see what happens. Nothing, so maybe A is the back. Now I'm going to put it in the back one. Yeah, that's a peak. So that is A at the back. When they tell us to go for L122B, we know that we have to go through. And we have done it, I think. Yeah, we've done it. Pretty simple. Now let's do a test here. I've set the thing for 1 megahertz, okay? Do this blind. I'm going to tune to 1 megahertz. There. There's our peak, straight on 1 megahertz. That tells us that the dial scale is now aligned. What I'm going to do next is I'm going to do the same for the long wave. Long wave is exactly the same. It's using that same loop system that we have for the medium wave. I won't bore you with that. I will show you which ones we adjust just for clarification, but then I will do that and then we'll see what happens with the shortwave. So they tell us to set to 405. Now 405 is again with the gang fully open on the right hand side, and we adjust 119D, that guy over there. And then we set to 160 kilohertz and we adjust 119E. Oh, this is easy. 119E again on the same row or same column, that bigger one at the bottom. And that is all we need to do to adjust the oscillator. Then we go on to the antenna and the mixer circuits, And for that, they tell us to set to 375 and adjust C113 and 119B. So 113, the antenna circuit as expected is over here. 113 is that guy over there. And what did they say? 119B. 119B is, again, there we go, same column, that one there. And the last stage is set it to 160 kilohertz and adjust 122B. And as we saw, 122A was the one closest to us in the back. 122B is the one that you have to pass the trimming tool through. So I will do that and show you the results. Right, I've done the long wave and this is the result. I've got a 400 kilohertz signal coming in. It's exactly on 400. If I change that to 160, let me get the noise down. We are again exactly at 160. Now here's a slight problem. If I put it at exactly 250 and I change the frequency on the signal generator to 250, it's there, but it's not the peak. Watch. That's the peak, so it's slightly off. What this tells us is that the linearity between the scale and the tuning condenser foils or blades is not perfect. You can adjust that by twisting the edges of the outer blade on the tuning condenser. That's why they do that when you want to create linearity. That is not something you want to go into when you're doing a restoration. Believe me, believe me, I know. Once you get those things messed with, it's a nightmare to get them back. So I'll leave it as it is. We've got a good alignment at this end. We've got a good alignment at that end. In between, yeah, it's a little bit off. So if I want to listen, say, to Radio 4, BBC Radio 4, which is at 198, I come down here and I should get it there. I'll probably get it there. But you know, the band, the actual bandwidth of the long wave signals is so wide that it really makes no difference. You know, you sort of get it in the general vicinity and you leave it where it sounds best. That's what happens with long wave here anyway. Right, I'm going to carry on with the shortwave adjustments, and really those things are exactly the same as what we've done here. I don't want to bore you with that. I don't want to bore me with filming all that. So I'm going to set it up. If anything interesting comes up, I'll report back. Well, folks, all I can say is that that was pretty uneventful. I aligned all the bands. There's one band I'm not happy with, and that is the final one, the 13 meter band. The reason is that this thing starts at 20.6 megahertz. My signal generator goes up to 20. So, you know, to align it at 21.6 as they require to do, I think it's 21.6, you have to put it at 10.8 at half, and you have to really blast it. It's not as clear as the others, but the others came out very, very well. All you need to do when you align these bands over here is one frequency alignment. In other words, they give you one alignment, one position, and you align the oscillator for that, and then you do the other two circuits as well. And it's very, very simple. You just follow instructions one at a time, very carefully. Be careful when you insert the tool at the back. You have to sort of feel around, because some of them, the ones that are on the surface are easy. The ones that you have to go through, you have to sort of, you know, twiddle around, feel around till it gets into the hole. And when you feel it going into the hole, you have to be very, very careful. But all the bands are aligned. They're aligned very well. I've done a few tests on random frequencies, especially around, obviously, where the alignment point is. They're exact. To the edges, they go a little bit slightly off in some cases, not in all. But overall, I'm very, very happy with this. I've now come to the final straight. The one comment I've got to make is they tell you to align this with the wave rod antenna. And I've had to sort of tape the back of the case, because that's where the antenna is, and connect the wave rod to the respective point over there. But it's sort of taped to the back of this case so that it can stand up. I haven't finished that yet. I need to do just some final cleaning, and then I can put this on and I can demo the radio for you. Yay. Okay. Nearly there. And finally, here she is, folks. Time for a twirl. She looks good as new, believe me. Absolutely stunning. Everything was put in properly. It's a pity about that missing tooth over there. But everything that's leatherette's been polished. Likewise on the sides, the plastic at the back has been polished. You might note that I have not taken that off. That's got a name on there. And I don't know whether this has any particular significance to the owner. So I decided not to take it off. So what I'm going to do now is I'm going to plug it in and we'll see what we get. I'm going to use my mini whip because I want to see just how good this thing can be. The rod antenna is very, very high, very, very long, but I still think the mini whip will beat it. So let's do a bit of a demo. Let's start with FM.
Sempre que a RFM ganha alguma coisa, tocam as trombetas.
E o que foi desta vez?
A RFM é novamente considerada como rádio com maior relevância e reputação emocional de marca, de acordo com um estudo independente realizado pela consultora On Strategy.
Musical no seu propósito. Sem mostrar que a musicalidade não está só no canto.
This band is completely full here. This thing's picking up stuff from everywhere.
Não são nada musicais.
These are stations that I normally don't receive out here. This one is doing a fairly good job of picking them up. FM's done. Okay. Let's try long wave. It's late afternoon, so it's not really the best time, but we'll see what we can get.
و23 درجة متوقعة في العيون مراكش وبني ملال.
Just getting traces of BBC Radio 4 there. It's sort of getting that station from Ireland, but not good enough to listen to. And of course, my faithful beacon. Medium wave.
Igualó más o menos a 45% cruz. Hay que tirar como... Sacó el man de toda la vida. Las 8, las 7 Canarias. La ronda informativa de tipo.
Los ataques de Rusia.
Alti saca a la derecha para... Presionado por Bryce Méndez. Llega parejo. Pero Rulli desde el punto de penalti. Bryce Méndez llega parejo a la derecha, a la divisoria. ¡La rosca! ¡Portería! Encarga.
Las fuerzas rusas, según la inteligencia.
Very good for this time of day. Let's try shortwave. I'm going for the 90-meter band. Maybe this time of day we'll be able to pick up something. I'm not sure.
مساحة المحافظ بإجمالي 383 ألف.
featuring a map that shows a disputed land declared by China to stake its claim to large. That's what state media reported Saturday. The U-shaped 9-line is used on.
That was 19 meters, 25 meters.
Superamos en el estadio de los Juegos del Mediterráneo en ese partido loco, Adri.
The World Bank on Friday released brief updating Vietnam's economic development in March, stating that the economy continued to show resilience and is recovering, although downside risks have heightened. Available data suggests
but the rest of
Organizations such as Islamic State, Al-Qaeda, and the Houthis, an ethnic rebel group who control much of Yemen.
يأتي من أمطار الشتاء القارس بالإضافة.
Let's try one down. Those others will only be in the evening, but 31 meters we might be able to get something now.
numbers. It's a great success. It's a great success. The countermeasures, the concept of a closed.
Kínai több ezer éves gyógyítási tapasztalatain alapszik. Ebben különbözik a modern akupunktúra.
Parents d'élèves du lycée français de Moscou interpellent Paris. La reprise des cours sera en distance. Müzakere eden barış hedefine doğru atılan etkili adımlar olduğunu belirtti. Uluslararası toplumun diyalog ve müzakere
Embarcación de por momento.
As well in all how we need it today.
Passé pour ces garçons de 10, 12 et 14 ans, pas de lien pour se connecter.
Shortwave 2 here is the band that's usually more active in the evenings. I've put it on narrow because there's a lot of stuff close together here, so you need to be more selective.
Le développement de la Russie, malgré le fait que la Banque centrale précisant que le PIB de la Russie chutera de 8%. قانون العقوبات المغربي
Oh, got some amateur band here. Let's put on the BFO. Put it on narrow or sharp.
El abuelete. Es de aquí 3000. Yo pienso que aquí sí quedó claro, está 30 mantenidos. Una bestialidad. 3009 mantenidos. Así que nada, pues, todo el director.
There we go.
El abrazo. Seguimos en contacto.
Well, you can listen using the BFO, listening to single sideband transmissions. Tuning it is very, very touchy. You've got to tune with your tuning dial, with your tuning control, as well as with the BFO, because it could be upper sideband, lower sideband. You might have to play with the gain control. If you have extremely high gain, if it's someone that's really close, you might have to lower the gain. So yeah, it's a bit of a difficult thing to do, but it can be done. And then of course, down here, we hardly get anything. So that, my friends, is the demo. And this is the result. I must admit, this thing started off in very, very good condition, which always helps. There is one light missing, by the way, before I forget. This light here is missing. And I'll just mention to Tiago, he can probably find one. This would probably use one of those single cell torch batteries. You need a 1.5 volt, not batteries, bulbs. You need a 1.5 volt bulb. Now here's the problem. You could actually wire it so that this thing comes on with the power, with any power. At the moment, it's connected only to the battery. You need that 1.5 volt cell in there. So these bulbs are all 1.5 volts. If you put in 12 volts, you have to current limit them or change the bulbs themselves. I also thought of swapping them out for LEDs, but you can't do that because 1.5 volts is not enough to drive an LED. You'd need about 2-3 volts. So again, I'll leave that out. It's probably easier for him to find a bulb for this. But it is working. I've tested it. Those bulbs are working. I've tested them too. And I'm really chuffed. I can now say that I've done a Zenith 7000. Tiago, thanks a million for the opportunity. I really, really am pleased that I got a chance to do one of these. Who knows, maybe in the near future another one will come up. So all of you who followed this restoration, repair, restoration, whatever you want to call it, I want to thank you for your company. I really do hope you've enjoyed it. I hope that it inspires you to restore your own if you have one of these. These things are gems. Really, they are gems. Once again, I'd like to thank you for watching. If you've enjoyed that, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon. Links are at the back of the video and in the description below. Thanks for watching. Bye for now and stay safe.